comments before we move on to chapter 3? So far so good? Okay. Alright, so let's move to chapter 3. The measurements of demand forecast, or not demand but forecast accuracy. So we have discussed the reason before we jump to any model. The reason to introduce the measurements, before we jump to any model, we need to know, okay, after finish this chapter, we need to know, okay, if a manager, if a client give a project to us, how can they or how can we tell them which model is better than another model? You can definitely argue, okay, there's no best model. Every model has the constant pro, but that must be some objective measurements. Well, in the final day, you have to argue, okay, my model is better than. Usually we know that it's by like the accuracy, error, but think about if we have a complex profile of products, right, 100 different products, then it's really hard to argue in a very straightforward way. You will say one product, model 1 forecast better, the second product, model 2 forecast better. Then how do you argue that? So that's why we first introduce these 3 measurements here, which can handle n products. You can increase n to 1 million. That's fine. Just plug them in, right? Then you will get just one number, comprehensive number for your overall forecast accuracy. So we have discussed MAD, MSE, MAP. A quick review. What does MAD represent? These 3 data. MAD means what? Mean what? Average. Deviation. Great. What does MSE mean? Mean square error. Great. Last one, MAP.
Mean average percent error.
That's great. Okay. We do have some students really guess the idea of this one. Okay. First example. So in this class, we have in many chapters, almost every chapter from now on. Since it's a very quantitative class, besides what is qualitative stuff we have discussed, we definitely need to do the examples together in the class, even in the class. So that's my way of teaching that. Okay, I will give some time, save some time in the class. So everybody should bring your calculator and pencil or pen to the class because we will have time for you to do example like this in the class. So, okay, this is the first example we'll go through together in this semester. Now we have one product, but have 5 different periods. Okay. So now n equal to 5. I want first to remind you. So this product with the 5 period, you can think about weekly demand. The first period, the actual is 107 and the forecast is 110. The second actual is 125, forecast 121. Similar until the 5th period. The actual, let's say demand is 108 and the forecast is 109. Now we want to calculate MAD, MSE, and MAP correspondingly. This table already gives you the way how to do that step by step. First, you need to calculate the error, which is actual minus the forecast. Okay. I'll ask you guys first one. For the period 1, what is error? Period 1.
-3.
-3, great. Just plug them in, right? 107 minus 110, -3. Similarly, you can get the forecast error for all 5 periods. And then you take the absolute value because for MAD, last page, if you don't happen to print out the slides, I really recommend you now to copy down these 3 formulas because you have to use that in 1 minute. So, if you remember here or look at that, MAD, we need to calculate the absolute value of forecast error and sum them together here. Sum them together divided by n, which you will get MAD. For MSE is different. We square the error first, right? And then remember the denominator here is n minus 1, which is 5 minus 1 is equal to 4. And then we get the MSE. MAP, first we have to calculate the percentage error for each period. Sum them together, divide by n, what gets MAP. So give first 1 minute. If you don't have the formulas, please write this as soon as possible because we are moving to the next page and give you some time to do the example by yourself. Everybody gets the formula? be quick because I will work around. I will see whether you have the formula. If you don't have that, that's some problem, right? I give you some time to write down and then give you some time to do the examples. So definitely I suggest everybody print out the slides before come to the class. The reason is we will have the open exam anyway. After finish 3 chapters, you still need to print out the slides. I believe so. Unless you are really smart, very confident. So you should better print out before the beginning of order as the beginning of this chapter, and then you make some notes. Then it will be helpful when you take exams. Everybody finish that? Okay. So can we move to the next page? Okay. Now give you guys 5 minutes, maybe more, but let's first have 5 minutes. Try to do that by yourself. Calculate the MAD, MSE, and the MAVE. Change your jersey. It's now belong to Bayern Munich. Don't you know that? Vidal has transferred from Juventus to Bayern Munich.
I'm just impressed you know that.
I'm a soccer fan for more than 25 years, so how can I don't know? I'm a fan of Inter Milan, so.
Okay. I had the jersey then. I have the Tevez one too, but he went to Argentina. So.
Okay.
I gotta get a new one.
Okay, but you can definitely at least get mad, right? So it's take the absolute value. So it's 3, 4, something like that. Okay. For MAVE, I would say for MAD and MAD, you don't need any calculator. But other two, remember to take a calculator in the future. Okay.
MSE and MAPE, you need the calculator in the future?
Yeah.
Oh,
Most likely. I don't need a calculator, but I would say my students because I have mathematical background.
Use all your numbers
Okay.
before and then just square.
Yeah, but I thought so you gotta buy about the actual game.
So
Yeah, you can use your cell phone calculate this time, but next time, everybody please bring your calculating device. No cool?
I'm just looking at like the part, the MSC, what's it, it said divided by the actual again?
MSC is a square. First square the arrow, right?
Yeah,
First square the arrow, and then divided by n minus 1. You see that one? N minus 1 is the denominator. N minus 1.
yeah,
so what's the top?
When I
It's
wrote
the
it-
actual minus
Uh,
forecast square.
that is actual minus
that's the reason
4
Jim
divided
has
by
to
n.
copy the formula first.
That's what it said divided
So
by
the
actual.
actual
Divided by
Yeah.
would be
actual minus
107
forecast.
minus
Square.
the forecast.
So it's an arrow.
110
It's arrow times square.
divided
is
by
9,
how much
16.
is n? So that's
And
5, right?
Jack?
Jack. Okay.
That's Ryan.
Oh, that's right. Have you finished that?
About to say, isn't
I
it?
finished Mad,
Matt, what's your
Oh.
results?
Damn, I wish I
Okay,
could calculate,
great.
bro. This would be a lot easier.
then MS.
And
I
it's like 9.75.
was trying to do my head.
That's
grind.
great.
I don't have my calculator.
Alright.
So,
I need
107.
Maybe, okay, maybe just do that step by step. So last column, you have to put the percentage error for each period.
0.6.
See that last
So-
column?
So it's error.
It's arrow divided by,
4 or 5.
if you look at the formula, yeah, actual, that's right. So it's the
Oh, no,
absolute
you square
value
each number
arrow
individually
is
and then
3 first time, right? Divided by
I
107.
did what you told me.
And he said it was.
That's the first one.
And then you add all those up when you.
Yeah. So you work as a percentage.
He said 9.75, right?
That's right. That's right. For MSC.
Yeah.
What did you get for
You
math?
good, Nemo?
I'm about to do it now.
The first one?
So to put them at, you do the
Oh, wait, you said
minus
add?
forecast.
2.6.
N equal to 5. No, it's not just
Oh, it's
for
just
compute.
the
You have
sample
also take the also take the
Yeah,
absolute
sure.
value. Yeah, that's
So it's 3
take the
divided
absolute
by
value because
107.
if you just calculate forecast error, it can be
Your first one is your first one.
So it's just like
But then,
each one
okay, for your math, right?
divided by 107.
Yeah, I think you got it.
Your math, you did the 107 minus 110 divided by
You
5.
just write the next columns. Absolute value
For
of
your
arrow.
math,
That's
you
what
did the 107 minus 110 divided by 5.
arrow. Absolute value of arrow.
So it would be 3 divided by
This is what the formula said,
That's
right?
right. N equals 1. Because N is the, you can think about sample size, whatever. Yeah, this is a little different with sample size, but we have 5 periods. So we're talking about a comprehensive forecast accuracy
Add just these
over 5
numbers.
periods. So that's why.
Then, once you get that, so you got 1.8
Yeah, you got it.
Yeah, 2.6.
and divided by 5.
1.44.
What did you get?
2.2.
Okay, great. Yeah. That's the
Man,
same
it
result.
should be 2.6.
Here's the sign-in sheet run.
Oh, here's a sign sheet.
Let me just get it real quick.
I
appreciate it.
J. 2 point.
Well,
Last
like
one
they
is a
basically
little
said,
different, but it's
like,
okay.
they got
but
these numbers, but
you
then
should
that's
get
the
something
R, all the numbers,
between
and then
2.22 and
the
2.21.
value of it.
Yeah, so it's
So-
not negative.
I appreciate it.
So then, can we do negative? Negative 3, wait. Negative 3,
That's
3,
I just did the first two, but like there's no.
It makes
so
sense.
much, like the decimals like 3
5.
Great. Check. Right?
107 was.
Alright, so I'm right here, like you got all the 0, 2, 8.
Alright, so I have seen many students have finished all of them or at least part of the question. So let's do them together. So, everybody have, I didn't see anybody had any problem to calculate the error. So who can tell me the error for the first one?
Negative 3,
Negative 3.
4, 3, 2, negative 1.
Okay. And then, write this down, 1, 2, 3, 4, 5. So the second one is the absolute value of the error. So it's equal to 3,
4,
4.
3, 2, 1.
Okay. Then we can calculate the math very easily because if you remember the formula from last page,
The exact same.
which is just simply summation of the absolute value of error divided by n. Then what is n? in this question. 5. Well, I want to remind you, sometimes the n is determined by how many period you make forecast. Sometimes it's determined by how many products you make forecast. Sometimes even determined by period multiplied by the product. You think about it, if you have 10 products, you make the forecast for 3 periods for each product, which means you have 3 multiplied by 10, which is 30 different forecasts. Right? Because 3 products, or 10 products, 3 periods. So that's you have 30 different products forecasts. Okay, for period. Then you want to measure them comprehensive, which is n equal to 30. But this question is very straightforward. Only 1 product, okay, but 5 periods. So n equal to 5. And you sum them together. What is summation of the forecast error? Absolute. Who can tell me? 13 divided by 5, which is equal to
2.6.
Great. I believe most students get the correct answer. Jack?
What were you saying about the period with how many products? So like, right, you're saying that there's like 107 products in the first period. Is that what you're saying?
Just think of matrix. If that's 3 period forecast with 5 different products, then how many forecasts we have?
20.
Yes, right? Very straightforward. So if you want to measure comprehensive forecast performance for this past 4 weeks, for all of these 5 products, right? Usually it's like that. You manage it once you have all measurements of your forecast, not just one single product, not just one period, right? Then we have to consider these 20 forecasts, right? Clear? And then n will equal to 20. But you also have 20 actual demand and 20 forecasts for different products with different period.
So we'd have to do 20 different MAD formulas, is what you're saying?
Those 20 MAD just have 20 forecast error. Add them together to level 20, right?
Okay.
Because you have this matrix, right? Okay. A little bit hard, a little bit deep, but anyway, good discussion. Okay, so MSE, we have to calculate the square of error first. Any volunteer here? 9,
16,
16,
9,
9.
4, 1.
Okay. MSC, the only tricky part is that MSC should make you recall about statistics. When you calculate sample standard deviation, right? Anybody remember how to calculate sample standard deviation? I believe so. What is the denominator of sample standard deviation? Minus 1. Right? That's I believe some of you made a mistake before when you do that step. It's always n minus 1. But population standard deviation is n. So when you do the MSC, you should recall that it's always n minus 1. And who can tell me the summation of error square?
39.
39 divided by,
4.
and you get 9.
9.75.
Great. The last one, so it's percentage. Okay. For period 1, what is the percentage error? Any volunteer?
2.8.
How do you guess that?
You take the absolute
3.
error value
Mhm.
divided by the actual, which is 107.
Then you get
2.8.
2.8.
Well,
And-
I mean, you have to.
Yeah, you have to multiply by 100. That's correct.
Right, yeah.
Yeah.
So
Yeah,
it's
but
like-
it's your choice. You times 100.
There you go. Yeah.
And the second one is equal to
3.2.
3.2. Third one,
2.61.
1.61,
1.69.
69,
1.92.
1.92.
Yep.
Okay. So Jonathan, what is the summation of this number?
It's 11.23.
11.23
Divided by
summation. Maybe. Divided by 5, which is equal to
2.244.
How many decimals do you want us to keep on?
Yes.
for the exam, 1 digit after the decimal. So basically, when you do the calculation, you should keep 2 decimals, and the final step is round up, round down. So that is basically
So keep 2 on the steps and then
round up or round down in the final step. Yeah, if you don't keep 2 digits, well, that's you for just for the exam or homework. Yeah. For example, homework you should keep 2 digits decimal, but for the final answer I require 1 digit decimal. Yeah. But yeah, if you give me 3 digits, I'm more than happy to look at this, what is accuracy or not. Okay. Any questions or comments on this example? Not hard, right?
Oh yeah, I have a question.
Sure.
Alright, so for the first error in the bracket, all you did, you just shifted everything.
This one?
Well, the next one.
This one.
Yeah. So all you did, you just shifted everything. So instead of the negatives, it was just gonna be positive.
No, this is not the bracket. This is the absolute value.
Oh, the absolute value.
Okay, this is not the bracket. This is I'm thinking about this is bracket. Though.
Oh,
This is absolute value.
Oh yeah.
Yeah, that's the definition of calculation math. The reason is if we don't take the absolute value, the error will cancel out by each other.
Okay.
You think about one item or one period you have the forecast error of 10. Another period you have forecast error of negative 10. If you don't take the absolute value, you cancel each other, you say you have a perfect forecast, which is totally wrong, right? So that's why you have either to take the absolute value, make it positive, or take the square. That's the same idea. The idea is that we want to keep all forecast error become positive. Or you can take the absolute or take the square. So that's 2 methods to deal with this situation. Alright? Question?
Oh no, I'm sorry.
Okay, great. Okay, next topic we're talking about qualitative versus quantitative forecasting. So qualitative techniques permits the inclusion of some source information, such as human factors, which can be very important for forecasting. Consider our customer, most of our customers are human beings, except maybe some maintenance parts for machine, but most of our customers are human beings. So then human factor definitely has a huge influence on our forecast. Personal opinions. Well, when you make the forecast, you can build a perfect model, but the final decision is still done by manager or director, whoever use this forecast. And also different department, they can adjust your forecast a little bit. No, that's exactly happen in all industry. For example, when I did a consulting job, we give the demand forecast for like 13 weeks to our clients. We give the permission for a lot of users. I give them permission for like 20 different users, from the entry level manager or shift manager to higher level director. They can all view our forecast results. But we will only give, like, depends on company's requirements, like 3 or 4 people permission to override our results. You know what override mean, right? So they can change our results. They think, okay, Charles, you give the results. Forecast is 100 units for chicken wings demand next week. I don't like this number. Whatever reason, I think it should be 120. Okay, I give you the permission for 2 or 3 managers. They know what they're doing. Basically, they have to know what they're doing. They can override that based on their personal opinion. The reason is obvious. No matter how fancy or how hard of your mathematical model, how professional, how much knowledge you know as a PhD or master or to major, whatever, but still, you lack something, then the person or the people handle the product directly, like their manager. They know what's happening every day. They know what can affect your model, which or maybe something you can't include in the model. They know that's what will happen next week, next day, and they can adjust, increase or decrease. They have some reason. They say we have an urgent promotion, and they say, okay, we have headquarters have a new policy, whatever. You can't change your parameters so frequently in your model. They know that. They will override that. This not just happen for Unilever or Procter & Gamble. It's happen for all companies. Another example is for Amazon. Everybody know Amazon is one of the best online retailing companies. It probably is the best. It's the largest, at least, online retailing company, and also it's a very high-tech technical company, right? When I worked in Amazon before, I did also a forecasting project for them, a labor forecast. So basically, my project is to forecast how many workers they lead each week, given their different shifts, night shifts and daytime shifts. So I asked the site manager, so it's the really boss of that big distribution center in Kentucky. I say, what forecast you use? Okay, he told me that the headquarters provided the demand forecast for him every week. The headquarters, Seattle guys, there are lots of very smart people dealing with computer every day. Amazon has one of the best forecasts in their industry, which is really hard. You think about it. Online retailing, oh, that forecast is really hard for them because of the fluctuation, but they did a very good job. But still, the site manager will override the results. Is done by so many smart people and software in the headquarters. This site manager will override. I ask him, okay, I say, Moore, his name is Moore. When you decide to adjust this number, how do you decide to increase or decrease? He can't explain. He says just by mind. He definitely knows what he's doing. He has the MBA degree. He knows all the things we talk about from regression, queuing theorem. We have a discussion about queuing theorem when I work there. And optimization. He knows everything. But he really can't explain in detail to me that's why he want to increase, why he sometimes want to decrease. That he can explain, but it takes some time. Just a personal opinion. But when you want to use a personal opinion, make sure you or somebody has professional opinion experience to do the override, to change that. Okay. The hence another fact, another thing we can do together. So usually these factors are difficult or sometimes impossible to quantify. Like my example to Amazon. Moore, he definitely know all the quantitative models. He know all of them. Okay, even he help us do that, but he can do it by themselves. But he's site manager, he don't have time to do that. He know all the things, but he can't explain quantitative why he want to adjust the forecast. Or he can't implement. Then he don't need to think in the next week. He has to do that, adjust every week based on different situation. Even for quantitative person, he has to do that because these factors, many of them are really hard to implement. That's the limitation of what we are introducing in this class. I always want you guys to know that, well, I'm personally very good at quantitative stuff. I also encourage students in business school learn a lot of quantitative. That's true because nowadays it's very important for you guys, for me, to have a good knowledge skill on quantitative. But that's always a limitation here. We can't ignore. We are doing the business with people. Always a limitation factors, qualitative factor we can't measure. Okay. Qualitative forecast is the thing we measure and introduce in this class. It's rely on hard data, usually historical data, and we'll develop an associative method which will be used for the future forecast. First category of the quantitative model we introduce is called time series forecast. So time series by definition is a time order sequence of observations taken at regular time intervals, which is easy to understand if you have one, two, three, 4, 5. Something like that. If you collect the data, like say every day, from Monday to Friday, or every week, then it's a time series historical data. So it's a regular time interval. You can't say I collect data the first day, Monday, and then Wednesday morning, Wednesday afternoon, and Friday. Then it is not, strictly speaking, in our class, it's not a time series. But generally speaking, it's still a time series. But here is not time series in our class definition. So it must be retrieve data, collect data by a regular time interval. And then we have this very strong assumption we have discussed before, like future value of this time series can be estimated from past value. So we know that is a very strong assumption, but for any forecast, we have to use this assumption, right? If that's what's happened in the past has nothing to do with the future, wow, then I'm unemployed for sure, right? I shouldn't teach this course because I don't know what I'm talking about because there's no forecast can be done, right? Since we have this assumption, then we can use the past information to make the forecast for the future. Okay, the last bullet. Forecast, if we are talking about demand forecast, right? If we have the past 5 weeks data, we want to make the forecast for the 6th or even 7th week. The forecast should be based on past demand rather than unit sales. First question, what's the difference between past demand and unit sales? What's the difference? Are they the same thing? Demand, sales. Are they the same?
Well, I mean, demand is just the expected sales.
No.
No.
Not really. We're talking about what's happened past. So both demand and sales are already historical things, not the expected. Expected, you mean that's have some randomness. Not really. Jack?
If there's a shortage or something, then you don't meet your demand, and you're looking at unit sales, then you're gonna do the same thing. You're gonna repeat yourself compared to meeting the actual demand compared to.
Great. Shortage. So what's the relationship between demand and sales? Which one is larger? Demand is always greater or equal to sales. Agree with me? Demand is greater or equal to sales. Anybody disagree with me? Please challenge me in this class. I know you probably don't want to do that, but yeah, probably know this point because it is true. Demand is always greater or equal to sales. One question: when will be demand equal to sales?
Equilibrium.
That's all.
Equilibrium.
When will the equality happen? Demand is equal to demand. In which situation you will reach the demand equal to sales?
When your
Equilibrium point.
when your forecasts are right.
No, not really. Consider other functions. So you can satisfy all. Basically, you satisfy all the demand. What's the assumption condition you can satisfy all the demand? For operations, not just in the forecast. Think about other important things. In which situation you can satisfy all the demand of your customers?
And errors.
Error?
Or we're just doing the actual minus forecast. When that's
You are still stuck yourself in the forecast. Think other things.
Customation. You could meet all of their.
Customization.
You can meet all the their consumer. You can meet each consumer's demand based off of what they want if you're customizing to them.
That can be very helpful, but very important thing to think about. There's one chapter we are learning in this class. Is what's. If you have enough what's, then you will satisfy all the demand of the customers. If you have enough,
Nothing. What inventory?
if you have enough what's. Question. If you have enough, you can satisfy all the demand for the customer.
Supply.
Supplier or inventory, right?
Yeah.
That's inventory. If you have enough inventory, correct, Sam. If you have enough inventory to satisfy all the demand, right? Don't stack in the forecast. Let's think about big picture because each chapter connects to each other in this class. It's not a challenging question, right, Sam? But we have to think out of that. So if you have enough inventory, definitely you require others in transportation departments or human resource, but most important, enough inventory. You don't have stockouts. Jack already mentioned in fact initially. You don't have stockouts, then your demand is equal to sales. But if you have stockouts, for whatever reason you have something in your warehouse, but you can't find it, but it's still stockouts, basically, then demand is greater than sales. Now come back to these points. Why our focus should be based on the demand rather than the sales? We know that sometimes they're not equal. Demand is greater than sales. Why we should use demand
So you
instead of sales?
control what inventory you have.
No. Now it's just related to the forecast.
The question was why do you
Why the third bullet is right? Why we should make the forecast based on past demand rather than the sales units? Why this is true? This is a big why here. Why? What's the problem if we use the past sales information to make the forecast?
Can be skewed.
And almost.
How will it happen?
Well, if it's unit sales and not like unit, is unit sales the same as unit price?
No, unit sales is sales volume, like how much you sales per day. Like yesterday you sell 100 chicken wings, 2 days ago you sell 115. But it can be different with demand. For example, yesterday you sell 100 new chicken wings because they're stock out. In fact, 200 of demand customer come here, but you can only satisfy half of them. So that's the difference between sales and demand, right? So what's the problem if you use sales units?
Maybe you know the units sold. You know it's not always constant, so you can't. It's not that reliable.
Some situation you are right if they have like a stable supply and but it's just you also you give a special case. Yeah, very good first one, but it's not the general answer. But not
Like unit sales could like exceed demand or be less than demand. No?
unit sales is always less what equal to demand. Yeah. What we want to forecast? What's the variable we want to forecast? Future what?
Future
Future demand, right?
Yeah.
Yeah.
What you want to forecast is demand. Do you want to forecast sales? I can tell you a very easy way to get 100% accuracy of sales forecast. Do you know how I handle that? I forecast 0 and I get 0 inventory. Bingo. I'm always correct because they can't sell anything. My sales is always 0. I'm not doing the business, right? So great. Well, I will never sell any Tiffany to any ladies because I don't have Tiffany jewelries. Easy, right? But this is not interesting for you. It's not interesting for you at all, right? What you really want to know is the demand, which is objective. Because sales you can control, there's a lot of constraints. Inventory, human resource. Demand is objective. It's determined by your customers, which you really want to forecast. You think about it, if you use sales to forecast demand, you know that. It's different variable, right? We should use the past demand to make forecast of future demand. That's the correct way. Sales, the problem we have already discussed, my extreme case, you have 0 sales for chicken wings in the past 5 days. What's your chicken wings demanded tomorrow? 0? No. Because you have stock out in the past 5 days for chicken wings. Very simple. If you use sales data for past 5 days, 0 to make the forecast demand for tomorrow, of course you will make a mistake, right? So that's why we should always try to use the demand, historical demand to make a forecast. Always remember that. Okay, but the big but here. Can we use historical demand information for some company or for most companies? Do you know the true historical demand? For example, Walmart. Do you really know how many customers want chicken wings for a particular day?
Nope.
Yes, if you don't have stock out, that sales equal demand. But if you have stock out, no. You don't know, you don't keep track, okay, who come in, look at chicken wings and then gets the turkey outside, right? They won't tell you, right? They won't tell you, right? Sometimes we have some idea which is done by like Amazon. How do you do that, right? They have stock out, they say add to your wish list, right? That's a good way you track unsatisfied demand. Okay, online retail, they do that. That's a reason they did it. They want, first one, they want to tell you as quick as possible if they replenish the inventory. The second, they want to track the true demand. Because if an item is stock out, you really don't know how many people really want these items. You don't know that. Then, online, so they have that. Some other thing did by Apple, they have like pre-order. Well, they can't satisfy pre-order. Everybody knows that. Like my wife, she placed the pre-order 1 hour than our friend. She was 2 weeks to get iPhone 6 Plus. So they can't say, but they know that from pre-order, they know that how many true demand even can't be satisfied now. They know that. So for many online retail stores, they want to use something they know that, or just simply to count how many people browse your website, this specific page. They can estimate. Well, that's a percentage. Maybe sometimes you random click on the page. You are not interested in this product, but for other customers, like 50%, they really want this item, or then they left because stock out. But for physical retailers, it's really hard. It's really hard. Maybe a customer service in Walmart really asks, what are you looking for? They say, sorry, we don't have that. But this information won't go to their database. Say, Charles come to the store, wants chicken wings, he can't find that. This won't go to the database. Then you don't know that. Then, unfortunately, many times, the only thing we know is the past sales. But you should keep that in mind. For example, I give you extreme case. Past 5 days, chicken wings sales is 0. You know that it's a stockhouse problem. It's not that because nobody wants to chicken wings. Then, when you use this information to make a forecast, maybe it's useless, so you should consider other factors. Right? That's very important. Okay. Good? Jack?
What about for like Apple or Microsoft or Oracle, like these technology industries where the technology is constantly changing, can they really use the historical demand? Because
The historical demand has little thing to do with the technology. Think about it, because just the human beings. You want iPhone 6, you want iPhone 6, you go to the website, it's also stock. Where you let Apple know, you just maybe simply wait, right? Then nobody will know that there's an unsatisfied demand from Jack about iPhone 6. Nobody knows that. No matter how fancy of your product, the technology like sales, why we can track that? Because every time you check out, they scan that, it's automatically to their database, so they can track that. It's just 1 second. But for demand is a human being's requirement, right? Maybe you think about something, you just go to the website. Who knows why you want to see the Amazon's website for iPhone 6? Maybe you just want to see the features, or you just say, okay, people go to iPhone 6, it's not a good choice. Whatever reason, it's really hard to track unsatisfied demand. So no matter how advanced of technology. That's a good way, as we said, a pre-order or wish list, but still, it can't track 100%. But for sales, it's really close to 100% accuracy. Okay. Answer questions? Any other question, comments? Okay, that's the dilemma here. So first, we have to be very clear that we want to pass the demand information if it's possible. Especially when the sales is very different with demand, then we should be very cautious. Secondly, for most situations, unfortunately, we don't have the demand information. Well, we only have sales, but still, remember, if we only have sales, we know that the stock out in this period, we should adjust. Ideas, usually many companies adjust that. If they have a very low sales volume, they will explore. Is that because of stock out or just because really low demand for this period? If it's because of stock out, they will adjust times like 1.5, whatever they think is reasonable to reflect the historic demand. And then use this transformation data to make the forecast of future demand. Okay. Time series behavior. There are several different behavior from trend, seasonality, cycles, irregular variation, random variation. Let's see some pictures and you can understand. First is trend. Who can tell me what's the trend here for the first picture? Positive trend or that's increasing trend, right? Increase trend. The second is very sort of cycle, right? It's have a cycle or economic cycle, whatever cycle. Seasonality. You can see this product is very popular close to April, whatever reason, and also very popular on the end of October. What's the difference between cycle and the seasonality? Anybody know about that?
Maybe the cycle is referring to the business cycle, in points of, recessions and,
Economic cycles.
right, and seasonal is more like the time of the year.
Very close, very close. Yeah, I think that's close to the official explanation. Is most
Right.
my explanation. Official explanation is that seasonality usually we talk about the really season, so it's by per year, like the each month or each week happen on this year. So each Thanksgiving, each Christmas. Cycle usually. In fact, I personally think seasonality is just a subset of cycle because seasonality,
Yeah.
of course, is a cycle, right? But the cycle is fixed by yearly base, right? Cycle usually talking about longer time period than 1 year, like a recession. You don't expect a recession to happen every year,
Yeah.
don't you? I don't expect that to happen, right? So probably as long as possible, but we know that those areas of decades or 20 or whatever years, the recession will happen. The booming will also happen when we come, right? Also stock markets maybe 2 or 3 years of cycle, but it will happen like real assets market. So cycle usually is longer than seasonality, and also it's not have very strict pattern. Like seasonality, we have like every Thanksgiving, the turkey demand though, I don't know how much increase, like 1,000%, something like that. But cycle, if you can predict the next recession time, you will win the Nobel Prize. It's simple, right? It's simple work for you. But cycle, we have some pattern, but it's not so easy to forecast. So that's the difference. First is a longer term cycle. And second, it's not so strict follow a pattern like seasonality. So, first model in this class, which is called Laïu method. So we'll learn some Laïu thing as the beginning of, as the first model, and then we'll go to some complex, most Laïu thing. So Laïu method, we will use a single previous value of time series as a base for forecast. In fact, I already give an example of Laïu forecast. For a very Laïu method I use. I say, I'm a very good weather forecast man. For the next minute's weather, what I use? I use the weather now to make forecast for next minute, which is the exact Laïu method. Okay. So if a stable time series, the forecast for a time period is equal to the previous period. That means you want to forecast for the weather for the next minute, you just simply use the weather now for the past to make this forecast. If the products or service, whatever you want to forecast, have a seasonal variation, have a seasonality, so your forecast should be equal to the value of the series last season. One example is like Turkey, or let's say the next holiday. What is the next holiday from now? Is
Labor Day.
Labor Day. Okay, Labor Day is not a good example. What about after Labor Day? Halloween, right?
Yeah.
Halloween, you
What products will be very popular in Halloween?
Candy.
Candy, right?
And
Decoration.
Yeah. So if you want to make a forecast for the Halloween's candies demand, what you should use?
Last year.
Last year's Halloween, right? You can't use last week because it's totally different, right? So you should use last year's Halloween's candies demand to make the forecast of this year. So that's still a Laïu method, but it's Laïu method with a seasonality, right? It's so Laïu. Laïu method with trend. If the forecast is equal to the last value of the time series plus or minus the difference between the last two values. So I can explain here. So you can still use Laïu method, but since you know there's increased trend here, then you want to capture the trend to use Laïu method. Okay, that's a simple example. We'll do that together by the whole class. So let's say this is for trend. Let's say we already know, okay, our product has a trend. You need to capture what trend this means. Yeah. We want to use the Laïu method with trend to make our forecast for period 3 for these products. Now, any person can tell me the answer of this question.
48.
Will I explain?
48.
Great, that's correct answer. I don't think anybody gets why we get 48, but let's we do that together, okay. So it's Laïu method with the trend. First, we have to capture the trend. What is the increase trend or decrease trend? So we need to capture the difference between period 2 and period 1. So it's change path. So what's the difference between period 2 and period 1? 4, which is 44 minus 40. Then you can tell me, is this an increase trend or decrease in trend? Increase in trend, right? Our demand increase from period 1 to period 2. Then the Laïu method with trend is very simple. It's not just use 44 or last period demand. It's use 44 last year actual, okay, demand or sales, whatever you are available for you. 44 plus the change. This change can be negative. Remember, this change can be negative if it's a decrease trend. But here in our example, it's positive 4, right? That is 44 Laïu method plus 4 with trend. So here is equal to 48, which is the forecast for period 3. It's clear for this simple example? Okay. So when you are doing the exam, many students ask me before the exam, I want to. When the exam or homework question asks you about Laïu method, if they don't mention about the trend, then it's a pure Laïu method. It just use 44. If they want you to capture the trend, they will mention that, okay, it's Laïu method with trend. Many students make it too complex. If they don't mention the trend, simple Laïu, what's the period 3's forecast? 44, if the pure Laïu method. If they mention, okay, it's Laïu method with consideration of trend or something about trend, then you need to capture the trend.
So if they don't say now, you use the previous.
Yes. If they don't say trend,
They
they
don't
don't
say
say trend, they just say Laïu. That's previous one, which is 44.
Good.
Clear? Okay, great. See you guys on Friday.